role of data science and data analytics during a pandemic. Before we get started, let's do a quick introduction. My name is Joseph Holbrook, and I have been in the IT industry for well over 20 years. I've had the opportunity to work around not only databases, but also cloud-based systems, data storage systems, and also working in basic roles such as an analyst or data-based service providers. With that said, let's go ahead and talk about what we're going to be covering today and how it can really help you to understand where data science and data analysis can really play a role in understanding a pandemic. Now, when it comes to data science and data analytics, sometimes we can get a little confused over the terminology. I'll go ahead and discuss that as well. And then I'm going to provide you some additional resources for learning. And also, as part of the session, I'll be going through two specific tools that are free and online for you to use to play around with understanding how COVID-19 data could be used to understand the patterns, the behaviors, and other questions that typically organizations and governments want to answer. Let's go ahead and get started. Did you know that Amazon Web Services, Google Cloud, and many other service providers, and also I would call third parties such as the World Health Organization, have provided different tools that can provide you insight into what exactly has been occurring based on the records that have been generated around COVID-19. Now, Johns Hopkins University also has global indicator subsets that you're able to download and review for free as well. Data scientists can learn how to stabilize the data so that they can establish appropriate relationships between the data and bottlenecks around data. When it comes to AI and ML as well, these solutions are being developed specifically to address this pandemic and future pandemics. Every day, over 2.5 quintillion bytes of data are generated. It is more accelerated with the growth of IT. It is also important to realize that TensorFlow Research Cloud enables data researchers, for example, to apply basically access for free to a cluster of more than 1,000 cloud TPUs. Now, a cloud TPU is basically a TensorFlow processing unit. That is extremely powerful. It's much more powerful than anything you have on your laptop, for example, or desktop. So effectively, you're able to use a massive scale computer system, again, for free if you're basically qualified as a researcher. You also would be able to get insights around, for example, challenging areas and understanding, for example, where the data is coming from, how it could be applied, how it could be understood. Data scientists can also learn how to stabilize the data so that they can establish appropriate relationships between data and the data bottlenecks. Lastly, one of the biggest hurdles in AI and ML is actually having realistic expectations around the true capability of the technology. Now, AI and ML has been hailed as like the solution for everything, but in reality, that may or may not be the case. It can definitely solve problems, but we want to be realistic in understanding how AI and ML play into the world of using data to actually solve problems and asking questions around a pandemic, for example. Before we get started into the main content, just be aware, who is Quickstart? Well, Quickstart is an IT training company. We offer online job-ready bootcamp programs in collaboration with universities and colleges. Some of the organizations are listed there, such as Texas A&M University, Kingsville, Florida Atlantic University, Colorado State University, Northeastern Illinois University, Becker College, and Wagner College. So let's talk about the role of data science and data analytics. Now, one of the challenges that I think I need to clear up before we get started is to really understand what is data science and what is data analysis, because in reality, they're actually two different things. When we consider, for example, data science, it is really a concept that we're going to use to tackle what is big data. Now, big data is basically taking data from different sources and being able to take that data and bring it into, for example, a data lake, and also take that data and derive value from that data. In other words, ask questions against it, try to basically be able to derive value, basically. And the way we derive value is basically we're going to provide, for example, in our work environments or using a cloud service, whatever that is, tools to be able to do that. It could be anything from Apache, it could be Tableau, it could be from Google, whatever that provider is, we could use tools to really help understand the data. So data science is more a concept in a lot of cases, and then we have roles that are sort of under that. Data analysis is really a subset of data science, and automated intelligence is really a subset of machine learning. Data analysis, AI, and ML are all subsets, in other words, specializations of data science. Machine learning can be defined as a practice of using algorithms to extract data, learn from it, and then forecast future trends from that topic. Data science is really a broader term. Again, we're already aware of what data science is, and really the goal with data science is to bring together all these tools and specializations to be able to bring value to the enterprise. Basically, let's sum this up before we get deeper into the content. Data science, if we think about it, is really sifting through complex and large data sets to understand the connectivity of, for example, genetic codes and human diseases. Now, this is really applying it to a pandemic. So when it comes to like looking at COVID-19 or SARS or any other kind of data that's available, we really want to look at the data. And the way we would do that is to understand how data is intertangled between each other or connected for that matter. So data scientists, what they're doing is taking the data that's provided, and I'm going to provide you resources as well about where to get this data as well further when we get to the end. But basically, we want to be aware that data scientists are taking, for example, this data, these codes and diseases, that information that's generated, to be able to correlate the data to provide insight into how we could solve a problem. When it comes to data analytics, the way data analytics is going to be typically applied is really to process the large volumes of data that is derived from anything from clinical to laboratory reports to data scientists basically bringing in other areas. For example, it could also be, for example, death reports. It could be test results. Whatever that data is, it's going to come in a large volume generally. And the goal is the data scientists want to enable a more precise diagnosis by processing this data by using typically what's called a deep learning technique. And that's going to fall into the AI and ML realm, basically. And again, neural networks as well could be part of this. But basically, data analytics will be used again for other applications such as biotech, genetics, pandemic response, etc. Now, data analytics really, as compared to data science, is really providing the ability to process this data and to be able to understand basically where, again, the data is coming from, how it could be applied, what is the challenge that has to be solved. So it's really a way to look at the data. So let's go to a quick whiteboard, and let me go ahead and share my screen here. Okay. Now, one of the things that we want to be aware of, and let me share the screen before I forget here, is, I think this is screen 2. There it is. Okay. All right, so there's a few thoughts here, and we need to just think about it from a data science perspective. Like, how do we bring data from like all these different countries, and how would we actually take this data and actually ingest it? Or how can we process it? Or how can we actually provide a service around it? How do we get insight? How do we analyze it, right? So there's actually a workflow to this that really needs to be considered. So what I'd like to do now is take a minute and just provide you sort of a high-level overview of where data science and data analytics could be applied. Now, let's say over here, I have my user data. For example, I might have data coming from the CDC. I might have data coming from Johns Hopkins. I might have data coming from hospitals. Wherever this data is, this is data that, again, is being collected. So we want to ingest this data somehow. Now, when we create basically a data lake, we want to think of a few things here. And let me put that up here. So basically, we're going to want to create basically some kind of data lake. And this is usually part of what's called a big data platform. Now, as part of a big data platform, we generally need to be, we need to be cognizant of a few things. Data is going to come in, and we need to not only have a place to store the data, but we need a way to bring in the data. And this could be through any number of tools. For example, we may want to use tools such as Kafka. So Kafka could be a great solution as part of this. And then once we use Kafka or some kind of a messaging service, basically like a push, could be pull, but generally a push, you're going to be sending data into the platform, but we could also pull it. And basically pull would be going out this way. But basically what we want to think about here is we need a place to store it. And so when we bring it in, we also need to store it somewhere. And we could be storing this on a platform such as Hadoop, or it could be Google Cloud Storage. It could be AWS Object Storage. Could be any number of solutions out there. So once we get past the point of bringing in that data, we now need to consider a way to process the data. And let me just be clear here. So this would be basically our ingestion. And then this would be basically our processing. And then before we get to processing, we need to have a service. After we get to processing, we need some kind of a service, basically. And what I like to sort of point out is this is where we're going to provide value. In other words, it's one thing to have data, but it's another thing to actually understand the data and get value out of the data. Whatever that question is you need to answer, that problem you need to solve, this is where we need to start creating value. Okay, so we know that over here, we could use Kafka. We know over here I could use, for example, Hadoop. Now, what happens, for example, when I get over here? Well, I need to be able to process this data. So I might have a cluster. Now, typically when we use Apache-based big data services, these are very powerful open source tools that we could use different programming languages. Now, commonly Python's likely the most likely used 8 out of 10 times lately from what I'm seeing. And if you know Python, this is a really good way for you to start. So we could use Python or MATLAB or MILib, for example, any number of languages. But again, it depends on the platform and you know, your expertise probably as well. But with that said, we need a way to really start processing that data. We need a way to sort of start putting it together. I like to call the ingestion phase sort of, you know, basically to store it before we actually start using it. So this is where we're going to use it. And then this is where we're going to actually visualize it. And that's really the goal, because without visualizing the data, it's really hard to get value out of it. All right, so what are we going to use here when it comes to processing? Well, chances are, if we're using open source, we're going to be using a Spark-based processing capacity. And then we'll probably be using Python 9 times out of 10. But it could be MATLAB. It could also be other lib-based services, for example, whatever is appropriate. Now, for example, here, we may need to process that data and bring it together. And then once we get to this point of processing, I need to use, for example, tools that are going to provide some kind of intelligence. And basically, this could be Cassandra, for example. Now, Cassandra is a widely used tool as well that we could use. And again, I could use any number of tools depending on what I want to use. I could use a cloud-based tool. I could use Tableau, for example, whatever is appropriate. And this is where we're going to visualize. We're going to analyze. We're going to use BI tools as part of this. That is really what a pipeline is going to sort of be utilized in the world of big data and using data analytics. Now, once again, we know I could go use tools. I could ingest the data. I could push or pull that data however I want. I need to get it on a platform that I could start basically collecting it and then start manipulating it, basically processing it, and then visualize it. This is, again, your high-level big data lake type of platform. All right, now let's go over to the presentation here. And let me go and share the presentation here. Okay. All right, there it is. Okay. And let me go back to where it was. Okay. So we know basically now what a data lake could be used for, how we could use it. Now, we want to be aware again, we're going to use the right tool sets. I covered just some of the tool sets out there. And these tool sets, platforms, and services, whether we're using Spark-based, Google Cloud-based, Tableau, AWS, Oracle-based tools, whatever, we need to use the right tools to get the right insight. And the goal of using these tools is to be able to act on that data in some manner. The role of data analysts comes down to 3 things: visualize, learn, and solve. That's what you really want to be good at when it comes to data analysis. And especially if you're solving issues around a pandemic that is, we really want to be able to understand the data, the value of that data. Is that data actually accountable? Is it not? A lot of different things to look at. For example, here's just one example of Google Cloud-based tools. With Google Cloud, we could be using what's called a data warehouse or a query service. Now, this is a way that we could use, for example, a tool with Google Cloud to basically not only collect the data, to store the data, but also save the data and then ask questions against it. So what I could do in that diagram that I just went through, if we didn't have on-premise based services, then I could use tools that effectively have the same services in the background, like on Google, to be able to query, to store, and do the same exact thing. So the options are out there, basically. Now, I'm going to go through a data report and run the report here as well. And before I go to the demo, I just want to point out some sources. Now, the information that I'm using is all from public data sets. AWS, Google, for example, and Tableau all have basically free data sets you could use. You could also go to Johns Hopkins University or the World Health Organization or Worldometer to get additional data. And then SAS as well has additional COVID-19 related data you could use as well, and then the CDC. So just be aware that that data is there. So before we go to that slide, let me go and share my screen, the browser. And go back to the resources. For example, as far as resources are concerned, Tableau Public has basically a free tool you could download. And it's an application that you could use locally on your desktop. What's really nice about this is that it runs locally, so you could ingest the data and not have to depend on the cloud and deal with latency going back and forth to the cloud. So what we could do is basically go over here and question the data that I ingested. Now, for time purposes, I had to get this ready ahead of time. But what I wanted to point out is for those that are interested, you could go to the sample data under the public data area and download data sets. They could be in any number of formats like Excel or CSV zip files, and also workbooks or JSON, depending on the format. What's really nice as well is that the Tableau public utility allows you to go over here and open up basically a workbook. And again, if I had one saved, I could open it up. And then I go over here, I could have one saved locally as well. So as you can see, I had one there, but for time purposes, let's go over here. But what I'm trying to get at here is I could also create a new workbook. I could import it and just do any number of things. So what this is, just to show you what this data set is you could go over here and you could select basically one of the galleries. This is visualization, and I'm using basically the data here called, where is it? United States by Jeremy Blandley. Now, this was created, this workbook was basically created by this gentleman named Jeremy. And this is to enable you to learn as a data scientist, as a data scientist, or actually a data analyst student, or whatever your role may be, right? But with that said, this is actually a nice way to start learning about this. So what he has done is he created a workbook, and you go over here and download this and open it with the desktop app, which I just showed you. Now, to install this desktop app, again, is going to take probably about 10 minutes to get it set up and ready to go. For time purposes, that'll have to be on another video another day. But basically, I did want to just make you aware that it's relatively easy. It takes a little bit of time. Once you're ready to go, you then would download the worksheet. So what I have here is called the coronavirus COVID-19 in the United States. What I could do here is select any number of points on this map, for example. Or I can go over here and select basically this graph as well. So I could go directly to the sheet that this came from, for example, and look more at the details. I could change the colors if I want, any number of things. And I could go over here, for example, and look at it a different way. So as a data analyst, for me, I prefer bar charts or I prefer graphs. Some people, again, have different requirements. Maybe a pie chart will work, maybe it won't. It all depends, right? So it all depends on the type of data and how you're displaying it. So you can see here, if I want to map it out by state, I could do that. 188 cases, 94 in Alaska, in American Samoa, 94. So you can see here, I could drill down based on any number of requirements. I could change the color if I want, so on and so on. So with that said, there's a lot here we could do just with the data. Another thing too with this tool is if I'd like, I could go over here and I think, wait a minute. No, here. Yeah, so you can see here, I could change the view as well. And then I could go over here and add a new sheet. So what I could do is add to the data on top of the data if I want. And then the dashboard. I could also show a grid if I want. So you can see there that the grid shows up. But again, to go too deep into this is going to take about 2 hours or so. But I just wanted to give you some insight on what could be done with this. Now, if I go over here, I did want to point this out. Like if I go here, I could just go view data. And when I go view data, this is going to tell me, again, it might be a little hard to see here, but I could break down each state and it tells me basically, did it increase? Did it go up or down? What does it change? Went up 19%. So basically the number of reported cases went up 19% in that, basically time frame. And it basically went up for max date was the 24th. The max date is, so basically the lower limit was the 20th, and the upper limit was the 24th. So that's what, 5 days, right? When you add it up. And it basically tells you basically the cases and then number of cases for the max date. This is projecting again what could happen based on the current trends. That's the summary. And then I go to the full data, and this actually breaks it down by county. And it breaks it down as well, basically by over here, like Harris County, Harris, Texas. I think that's, I believe that's a city. Some of these are counties. I believe these are just cities, actually. Let me see, does that say US? It's not clear, but again, I'm guessing that's the city or county on how that is actually relegated, but I'd have to take a look at the data a little bit more. But you can see here, it says novel coronavirus, tells you that this is recorded by Johns Hopkins University, tells you when, and it gives you all of this information that you could look at. And you see there's a ton of information that has been recorded. It tells you everything from the percentage, how many cases were resolved, how they were resolved, etc. So that's just one example. Now, one more thing to think about too is you can see here, this is actually comparing against the world. So what he has done, Jeremy, is he added basically the data from the world and comparing it to basically the US. So the US really only accounts for less than 1% of the global total of deaths. So again, you know, whether that determines if you shut down the world or not is another story. But as you can see, that's sort of telling you like it is. So when we compare this to the world, we have a minuscule base number of deaths based on the date of this data, which is the 24th. So as you see, very powerful tools are available for free, for open source as well. And I could go over here and then select the sheet, and I could drill down another way. So if I don't like that view, I could go select another view, right? And you can see here that that probably doesn't look very good, but this is basically giving us what's called a moving average. And you can see there, this gives us like small blocks to larger blocks, so on and so on. So we have the chance here to dig down into the data and actually look at it 18, 20 different ways. So a lot of power with this. All right, so that is basically an example of what we could do with just Tableau. And then down here, I could just highlight each of these and drill down even more if I want. And again, if it's supported on the graph, it'll show up. All right. Now, this is basically the home page on the app. If I wanted to, I could go over here to a server. I could go to the web data connector and basically connect to a site that has a connector for Tableau, or I could build one. In other words, this is a way I could go to a website and just pull in data automatically if I want. And I could support different formats. Very powerful tool. And then what I could do is take the data and then save it to however way I feel like it. I go to a PDF, Microsoft Access. I go to a statistical file, save it, right? So if I go over here to, let's say, Quick Start, and I needed to create it first, but basically I could connect it to a file I already have. So I didn't create one, so I can't connect to it. But anyways, just be aware there's just so many tools here that are available for free. All right, now the next tool I want to cover is actually Google Cloud BigQuery. Now, Google Cloud also has free resources available around COVID-19 data. If you go over to BigQuery in Google Cloud, now BigQuery is really a tool. It's a query service is really what it is. So what we're going to do is ingest data from a data warehouse like Bigtable or any other resource, and then basically ask questions against it. This is a way that we could get different results. What I could do over here is I could go run a query, and this will print out, for example, the data, which was COVID-19 ECDC here, and ask, for example, again, against the data that was collected on COVID-19 worldwide, and then basically get a report done. So right here, what I did is I just simply ran a simple query that basically looked at the date, the number of confirmed cases, and I think I could expand that a little bit. And you can see there a number of deaths, confirmed cases, for example, the number of total deaths, and the countries and territories. And this is from the public data COVID-19 data set. And again, this is all freely available to you to run. And if you don't have a Google Cloud account, you could sign up for a free trial and use this for free anyways, as long as you don't exceed the thresholds. Okay, so when I run the query, you can see when I run it, this is going to give me all kinds of data. Well, looking at a table format may not actually be very useful for me. So what I'd like to do is I can go over here and go format. And I could also basically format the query so that I could execute it again in any number of approaches. I could also save the view if I want. And if I want as well, I could also go to Explore Data with the tool called Data Studio. Now this will give me a format to basically what I saw in Tableau, but it's for Google Cloud. I could go over here and format the data any number of ways that I feel like it. So we could see right here with Austria, they had a higher number of issues, for example, than other countries as compared to, let's say, Germany or to Indonesia. And that's based on the data that is available. And you can see there that I ingested basically 74 countries that are listed. I go over here to basically the chart over here, and you can see there it prints out basically a different visual for us. I could also go over here to a world map as well. And oh, that's not working because I have to configure that first. I need the dimensions added. Okay. And if I have the dimensions to the street view, I could do that as well. And then I could go over here and look at the number of records. This will tell us the number of record counts that was limited to 1,000. And you can see there, this is basically a graph time frame that sort of shows the spikes as needed. Then if I go back to the table, I get to choose the view any number of ways. With that said, just gives you a good idea of what can be done and how we can look at the data and visualize the data. The goal is to do what? To be able to ingest the data, to process the data, and then derive value from the data. Whatever number of ways you want to use, there's probably going to be an option for you. Okay, so you could see here, let's go run another query here. And also too, for those that are interested, it's not just basically available for resources. There's different types of data. For example, I could go over here and look at COVID-19 Italy, for example, by province. This will give us information by province, compose a new query, query the table. So this is going to select from the BigQuery public data set, Italy by province, and it's going to limit by 1,000. I go over here and look at the latitude, the longitude, the location information. So this way I could generate a map, province, and then confirm cases, let's say. Now, what I could do is, let's make sure I run that. And this is saying here, why is that? Select from something. Let me do that again. Select not must be, okay, must not be empty. What is this saying? All right, let me do it again. Just compose new query. I must have hit something. Okay. Okay. Good. Query the table. All right, select blank from the BigQuery data set. Okay, that looks good. And let's just make sure run All right, so that's just one issue. Okay, so now what I want to do, just want to make sure that the data set wasn't corrupt or something. And then I can compose a new query as well. All right, so let's go date by region. Compose new query. Oops, compose new query. Okay. So I'm going to go ahead and select the date, region name, latitude, longitude, location. And let's select, let's see, one of these, number of deaths, confirmed cases, and recovered. All right, so I just ran that. So that worked. Okay. So I have a lot of data down here. So what we really want to do is what? I want to go visualize that data. Now, when I visualize the data, I want to go explore the data. Now, I did want to point out we have another option now. Because it picked up that there's a location information, we could also use a tool called GeoViz. So when I go to GeoViz, this is a BigQuery tool, and it'll basically, I have to authorize this. And it'll run that query. And you can see it'll drill down right there. And it's not visualizing it. It should be working, but it's not. Okay. One style. All right. And anyways, I won't play around with that. Let's go over here. And let's go ahead. And anyways, it generally would work, but you could refresh it and try it. And then let's just go over here and let's go ahead and run the query again. Okay. Explore the data. Let's go to Data Studio. And something's missing in the data. But anyways, it worked earlier, but now it's not working. It's really weird. So location's there. But what should happen again is it would let you explore the data visually. It could be, again, something just isn't there, or this does use basically GPS coordinates. It could be that the service is just down, whatever that is. Generally, this works fairly straightforward, easily anyways. So with that said, this is just really to give you an idea of what we could do with the data and break it down by region, by trends, by whatever we want to look at. And as you see, there's a lot of other information around COVID-19. All right, and then also too, with Google-based services, you also have access to all this other basically sample data that's available from any number of sources. So I encourage you to take advantage of that, to play around and learn.